Dear students, in this video I am going to discuss IUPAC nomenclature of coordination compound. So when you heard the name IUPAC nomenclature, you already are familiar with IUPAC nomenclature of organic compounds, and you already studied IUPAC nomenclature of coordination compounds when you are in PUC. So now we are going to study little bit in detail in your bachelor degree courses. So when we come to IUPAC nomenclature of coordination compound, just like organic chemistry, you must keep some of the rules in order to name the compound. So when we come to coordination compounds, here three main entities will come. One is central metal atom, ligand and counter ion. So in order to name those, you must familiar with these rules. So now let us see the rules one by one. So that is, so first you know how to name, order of naming complexes. There are different types of complexes we have studied. You must know how to name different types of complexes, and you must know the naming of different ligands and the numerical prefixes used to indicate those ligands, and order of two or more different ligands are present. We must know how to arrange those ligands, and name of the central metal atom, and name of the polynuclear coordination compound, and naming of ambidentate ligand. So now let us first come to the order of naming complexes. When we come to order of naming complexes, there are three types of coordination complexes are there when we classify based on their charges. That is anionic complex, cationic complex and neutral complexes. So in first, if you take ionic complexes, that is either cation or anionic complexes. So first we are going, while naming, first we are going to write the positive part of the complex. Then we are going to write the negative part of the complex. So if you take ionic complex, it contains coordination sphere and counter ion. Either counter ion is positive or coordination sphere is negative, or coordination sphere is positive or counter ion is negative. Both the possibilities are there. So in both the cases, we are going to write positive part first, either it is a counter ion or coordination sphere, and negative part next. You just see this example, this complex hexacyanoferrate complex. In this complex, so K plus potassium positive and the whole complex FeCN6 is negative. So we write potassium first and this FeCN6 next. We just look at the name potassium hexacyanoferrate, hexa because of 6 cyanide. So positive first, negative hexacyano next. And if you take a negative complex, so positive complex, so this is positive, chloride is negative. So while naming this, so we are going to write, so this coordination sphere, so hexa amino cobalt, there are 6 chlorides or 6 amine groups are present. That's why hexa amino cobalt 3 chloride anion next. First we are written cation. And in case of neutral complex, the name is written in one word. So here also, so triamino chloro cobalt. In neutral amine there is no such cases. In neutral coordination complexes, there is no question of positive part and negative part, because neutral complex doesn't contain a counter ion. So entire both ligand and coordination sphere which is present in a coordination sphere. That's why, so here no need to consider so these above rules for the neutral complexes. And along with that, we must remember another important rules. So now we understood naming of a coordination complexes, that includes counter ion. But if you take coordination sphere, the coordination sphere, that is the moieties which is indicated. So this is coordination sphere. It contains only metal ion and ligand. So while naming coordination sphere, first we always write the name of ligand, then we write the name of metal ion. So there we are not worried about charges. While naming coordination sphere, first we write the ligand, then central metal atom. Don't confuse between them. Coordination sphere is different. Coordination complex is different. Coordination complex includes counter ion, but sphere includes ligand and central metal ion. Don't get confused. So here, while naming coordination sphere, ligand name first and then central metal atom. And the oxidation, while naming at the end, we are going to indicate the oxidation number within the bracket. This is the rule we have to follow during naming the coordination complexes. Don't get confused. So while naming, in general, while naming, first we write the name of ligand, then central metal atom, coordination sphere, and complexes. If they have given counter ion, so we always write positive part of the complex first and negative part at the end. So this is the rules we have to keep it in mind while naming the complexes. So if it is not understood while discussing the rules, so you can easily understand while solving the problem. The next, naming of ligand. So if the ligand is positive, the name ends with IUM. For example, so you will look at the ligand, nitrate. So this is not nitrate, nitronium. Okay, this is a nitrosyl. Actually, this is nitronium. The name ends with IUM. If it is a positive ligand, the name ends with IUM. If it is a negative ligand, so the name ends with O. For example, bromine, bromo, fluorine, fluoride, fluoro, oxide, oxo. So hydroxy, hydroxo, cyanide, cyano, oxalate, oxalato, carbonate, carbonato, acetate, acetato, like this. You just look at this anion ligand. The name of the anion ligand end with O. So bromide, bromo. And neutral ligand, the name of the neutral ligand used as such. Okay, so now you understood how to name positive, neutral and anionic ligand. The only here we are not going to discuss positive ligand much in this chapter. So just remember anionic and neutral ligand. The name of the neutral ligand doesn't have any prefixes. So the name of the ligand used as such. But when we come to anionic ligand, the name ends with O, like this. Acetato, bromo, fluoro, chloro, oxo, like that. Next, come to order of naming ligand. Okay. So dear student, while discussing the rules of nomenclature in coordination, try to recollect the rules we discussed in the organic chemistry. Then it is very easy. The rules of the coordination compounds we follow, it is somewhat similar to the rules followed in organic also. So you look at here. So order of naming ligand. Now we understood naming of ligand. Order. So if the complex containing more than one type of ligand, more than one ligand. So for example, if it is containing more than one type of ligand, for example, if it is containing chloro, amino ligand, at that moment we are going to arrange them in the alphabetical order. For example, in between amino and chloro, amino comes first. First we write amino, then chloro. If there is a different ligands are present, we are going to arrange based on the alphabetical order. Suppose if identical or same type of ligand is present, at that moment we are going to express their number by using suitable prefixes like di, tri, tetra, penta, etc. For example, if there are 4 amine ligands are present, tetraamino. There are 6 chlorine, hexa, chloro, like that. So like that we are going to use prefix. Don't confuse between prefix and suffix. Suffix which is added after the word, suffix, prefix which is added before the important word, that is root word, just same as that of organic chemistry. So in case of polydentate ligand, we are going to use bis, tris, tetra keys in order to express their number. And one important thing is, so we are not consider numerical prefixes. Numerical prefixes means these di, tri, tetra are not considered while writing the name on based on alphabetical order. For example, don't get confused. So once again, order of naming ligand. If a complex contains different ligand, we express by using alphabetical order. If complex containing identical number of ligand, we express their number by using numerical prefixes like di, tri, tetra, etc. And if it is containing polydentate ligand, so suppose if it is a bidentate ligand, we are going to use bis, tridentate, tris, tetradentate, tetrakis. So these are the numerical prefixes we are used. But these numerical prefixes are not considered so while writing alphabetical order. For example, a metal ion containing 2 chlorine and 4 amino ligand. For 2 chlorine, dichloro, 4 tetraamino. This, so if you go this di and tetra, di comes first. No, we are not consider this di and tetra. So we are consider tetraamino dichloro. So we are ignore numerical prefixes. So we are considering only the first letter of the ligand while arranging them based on the alphabetical order. This is the rules. So these are the commonly used prefixes in the naming of ligands. And naming of central metal ion. While naming the central metal ion, so we know that there are two types of complexes: anionic complexes, cationic complexes. In case of cationic and neutral complexes, so there is no such difference, there is no such distinguishing terminologies we are used to name them. We are going to use the original name. For example, if the iron, so we use it as iron, lead, silver, like that. But in case of anionic complex, the name of the metal ion ends with ate. For example, let us see the iron name is ferrate, copper, cuprate, lead, plumbate, silver, argentate, tin, stannate. See, you just look at here. So this name comes only in case of anionic complex. But in case of cationic and neutral complexes, we are used the name as such. So this is the only difference you have to keep it in mind. Don't get confused. Only in anionic complexes, the name of the metal ion ends with ate. But in cationic and neutral complexes, the name is used as such. So this is the naming of central metal atom. Next, naming of polynuclear complexes.